Welcome back to Biology at Jay's house. Today we're going to talk about absorbing stuff. So I didn't collect homework, I didn't go over homework, but I know what you guys are thinking. Jay sure talks a lot, but what's the point? Woo! Today should be the 15th, but double check that before you put that in your notes. Pretty sure you're supposed to do this on the 15th. And today we're going to talk about absorbing. And when I talk about absorbing, I really just mean getting it into the blood. Now, the last unit was talking about how cells load the blood up with carbon dioxide when they're done. And at the alveoli, the blood swaps out carbon dioxide for oxygen and goes to all the cells. And then at the cells, it picks up carbon dioxide and drops off the air. But what about the other things? What about the nutrients the blood needs to carry? What about the water the blood needs to carry? How do those get in there? And that's what we're talking about today. So when I say absorb, what I really mean is how do we get them into the blood? How do we make it so the blood has the water and the nutrients and can carry it to all the cells in the body? And that's what today's class is. So please write down the point. And we have two notes today. So the first note is small intestine. A long, thin tube. Now it's called the small intestine because it's thin. It's not very wide. A long, thin tube that absorbs nutrients from the liquidized food. Now, if you remember, the teeth in the stomach liquidize our food. They make soup out of it, right? No matter what we eat, it becomes soup. And then from that soup, we absorb nutrients at the small intestine. And then we have a large intestine. That is a shorter, wider tube. So it gets its name because it's wider. It's not the long intestine because it's actually shorter. It's the large intestine because it is wider. So there's a shorter, wider tube that absorbs water from waste. And what that means is by the time material gets to the large intestine, it's considered waste, unless it's water. Then it gets absorbed. So pause the video, get these into your notes, and then come back. So pause. Welcome back. I'm sure you all did that. Okay. So first thing is, let's start with the small intestine. Let's get this out of here. It is long. It's like 20 feet long. What? Since a lot of you are, just under 6 feet, so that's kind of almost like 3.5, 4 of you. So it can range up to like 25 feet, as short as some are 18 feet, but 20 feet, that's a fine number to kind of keep in your head. And if you imagine kind of 3.5 of you stacked up on top, that's how long it is. And it's just coiled up inside you. So let's draw our wonderful human here with a nose and a mouth and a chin, right? And there are the arms, which aren't part of your digestive system. And remember, food goes in the mouth, not the nose. Do not put food in your nose. Comes down, and first thing it hits is it hits your stomach. And we remember that the stomach is full of acid, right? That's not super well drawn. Let's draw that again. And there's a little sphincter right there that shuts off, and a sphincter right there that shuts off. And so you have the teeth that physically break up food, make liquidized food out of it physically. You have a stomach that makes liquidized food out of it chemically using acid. And then it's time to party. So I'm going to draw a really accurate version of your small intestine. Ah! It's all the stuff that's really behind your stomach muscles. So that six-pack I'm sure you all have, that is your small intestine. Now, why is it long? Why is it so long? Well, what does it do? Oh, that's right. It absorbs nutrients. So the reason that the small intestine is so long is so that we get a nice long look at the liquidized food, get a nice long look at the nutrients. We have a nice long time to absorb those nutrients. If you had a really short small intestine, then most of the nutrients would get pooped out and they would just be lost to the toilet. But by having a nice long small intestine, what ends up happening is you get a nice long look as the liquidized food goes through these 20 feet of tube. That gives us a lot of time to absorb those nutrients. Now, the crazy thing about the small intestine is that's more or less the only place that nutrients are absorbed. And what that means is after the small intestine is the large intestine. And that's kind of this U-shaped thing that kind of goes like that, and then it exits. And if I removed your small intestine and I sewed your stomach directly to your large intestine, and that's your exit, and I removed your small intestine completely, you could eat all day, every day, and you would die of starvation because you would never absorb nutrients. So you could just eat birthday cake and Twinkies and all the terrible stuff that your parents tried to make you not eat. You just eat it all day and you would end up dying in 3 weeks, because you can go 3 weeks without food. In 3 weeks, you would be dead from starvation, even though you ate all day, every day. What? That's crazy. That's why we have a small intestine. That's why our large intestine is not directly linked to our stomach. Our small intestine is. And then the small intestine connects to the large intestine and flows directly into it. So if we follow food, we chomp it up physically at the teeth, goes down, we chomp it up more or less chemically in our stomach. It enters into the small intestine, spends most of its time here. Most of the time for food actually is in the small intestine. Spends a good amount of time in the stomach too, a couple hours in there. But in here, it spends like 12 hours almost. It can spend like 12 hours in here just absorbing nutrients. But once it leaves and once it goes into here, which is, of course, the large intestine, I guess I should rewrite. Once it enters the large intestine, we no longer absorb nutrients. That job is done. Once it enters the large intestine, you are done absorbing nutrients and it is all considered waste. So this is all to be poop. Everything in the large intestine is going to end up being pooped out unless you are what? Oh, that's right. Water. Delicious water. That's what the large intestine does. This green, so it kind of goes from one hip up to your rib cage, across to your other rib cage, down to your other hip and out. That's how long it is. So you can actually trace this on your own body. From a hip to a rib cage to the other rib, across to the other rib cage, down to the hip and out. That's how long it is. Much shorter, right? And all it absorbs is water. Where the small intestine, all 20 feet of it, absorb nutrients. That's the purpose of that. Now, As you might guess, it doesn't spend a long time in the large intestine. Once it gets here, it's waste. Do you really want waste sitting in your body for long periods of time? No, not really. Now, and all it's doing is absorbing water. It's going from liquidized stuff that was flowing through the small intestine to hard poop that comes out, right? And we want the poop to be somewhat hard. One, it's just convenient, right? And two, any water that we poop out is lost to us. We don't get to absorb it anymore. It doesn't, all that water, if we poop the water out, well, we're definitely not drinking it anymore. That's not going in our body again, right? So this water is lost if if it comes out with our poop. So we really want to absorb as much water as possible while it's still inside of us so that we don't lose water to the environment. Because again, that's gone. If it comes out the exit, we don't touch it, and we shouldn't. It's diseased and disgusting, and never the twain shall meet. So we really want to absorb water, and we want to absorb the right amount of water. What that means is if our large intestine does its job too well, if something goes too slowly through here and too much water is absorbed, then we are this thing called constipated, and we have hard like briquettes, that are painful to pass and really uncomfortable, and they can like back up and cause problems like further up the small intestine. It can even back up to the point where it like backs into the small intestine into the stomach, and that's a real issue. That's like surgery time. So we don't want it to go too slowly through the large intestine and pull out too much water, because then it's hard to pass, right? We also don't want it to go boom and fly through a large intestine, because that's called diarrhea, which again kind of can be painful and uncomfortable, but also all that water is lost. No! So diarrhea means that we're going to lose a lot of water to the environment. So if you have diarrhea, you should be drinking a lot of water to compensate for the water that you're losing, because you're not going to drink this, right? Don't drink it, period. I shouldn't have to even say that. So what we'd like a nice, smooth path through our large intestine. So the right amount of water is absorbed, and as much water as possible is absorbed, but not so much that it's hard to pass the waste. Now, the question becomes, okay, so small intestine absorbs. Okay, I'm starting to get this. Let's look at a new picture. All right. What absorbs nutrients? That's the small intestine. What absorbs water? That's the large intestine. And I want to spend the rest of this class period talking about how those are not checked, which means if the small intestine can absorb it, it will absorb it. If it's dissolved in water, the large intestine will absorb it and does not check whether it's a good idea. So things like small intestine will gladly absorb poison, right? It also will absorb things like alcohol and drugs and stuff that should not be in our bloodstream. So what does check it? And it is a thing that looks kind of like this. It has two lobes. Ultimately, they make kind of a large triangle. They're right in the middle of your belly, like right at the bottom of your rib cage. And it is called the liver. Now, the liver does a ton of things, hundreds of jobs kind of thing. It is the miscellaneous drawer of the human body. If we don't have an organ to do it, we just make the liver do it. So all the blood that leaves the small intestine instantly goes into the liver. All the blood that leaves the large intestine instantly goes into the liver. And the liver checks it. The liver checks everything that the small intestine absorbs and decides, hey, is this a good idea? Should that be in my body? And if so, it sends it out to the rest of the body. But if not, if it's disease, if it's a poison, and poison doesn't necessarily mean like in the movies poison. Alcohol is a poison, right? And having a glass of wine is completely fine. That, no problem if you're an adult and old enough and all that good stuff. But it is technically a poison. So your liver will actually absorb the alcohol and package it and keep it out of the bloodstream. Because do we want the alcohol in our brain? No. Do we want it affecting our heart? No. When the alcohol does affect our heart, that's called alcohol poisoning. And you get to go to the hospital, hopefully, because if you don't, you die. So be careful with this, right? So what happens is all the stuff that gets absorbed that shouldn't be, all the stuff that shouldn't be in our body and gets absorbed goes into the liver. And the liver pulls it out, and just the nice, clean, fresh blood. Clean, fresh blood comes out of the liver, feeding the rest of the body. So the mailman picks up the nutrients from the small intestine. That's upside down. Picks up the water from the small intestine, and then, as you might guess, goes back, and you can think of this as like the post office. And it goes through and checks everything. Because when the postman, let's say, and you guys are all aware of like a mailbox, right? All right, it has its little thing here, and there's a little handle. And when you throw stuff in a mailbox, you may or may not realize that the only thing that's in here is actually a plastic bin. And it just catches the mail. And then the mailman just pulls the plastic bin out. And he doesn't look through it, he or she, doesn't look through it, doesn't give it a second thought, just throws it in his little mail car and takes it to the post office. And the post office checks it out. Now, most of the stuff in here is good. There are letters that need to be mailed somewhere. There are the Netflix movies that you're returning, all that kind of stuff. But occasionally, people are kind of snarky and they'll just put like old newspapers in there and, trash, or, people can be pretty terrible. And that stuff needs to be filtered out. That's what the liver does. The liver takes basically all the mail that's been thrown into your mailbox, right? That's been thrown into your blood, and it runs it by the liver. And the liver pulls out any old newspapers or trash that